This video is about solving absolute value equations. When it comes to absolute value equations, they end up in something that's called a disjunction. That means that there's kind of two possibilities in general. So if I have the absolute value of x, and it equals a, I don't really know if x was a positive number or a negative number because the absolute value basically strips it of that negative. It's just how far it is from 0 on a number line. So because of that, we have to do a little bit of calculating. We have to try both possibilities and kind of see what comes out. So we're going to show this in a couple of different ways. Let's try this first example. When it comes to solving these, what I really want to do is get the stuff in the absolute value, the part that I've highlighted. I want that by itself. So anything with it, I got to get rid of. So in this case, the opposite of plus 2, I'm going to subtract 2 to make it go away. So subtract 2 from both sides, and I get the absolute value of 3x is equal to 876. And now that I have this, I've got my absolute value bars and whatever's inside of it on one side, and of my value on the other, I'm going to break this into two different equations. We're going to work on that disjunction. And it's really pretty easy. So this could be 3x equals 6, or it could also be 3x equals negative 6. We're going to solve both. Now this is a nice and easy one. All we really have to do here is divide by 3. Divide by 3, and we get that x equals 2. And if we divide by 3 over here, we get that x equals negative 2. So in this case, x can equal 2, or it can equal negative 2. We'll both get the result of 8. Let's look at something that's got a little bit more stuff going on. Number 3. This has got a bunch going on. It's going to take a couple of steps before we can even get to work on it. Now remember, I want to get the stuff that's in those absolute value bars by itself. So first thing I'm going to do here is get rid of that minus 2 by adding 2 to both sides of the equation. I get 3 times the absolute value of 4x minus 5 equals 19, 20, 21. Okay, now this is 3 times the absolute value. And I'm going to treat this absolute value kind of like it was its own variable, like an x or a y or a z or something. So I'm just going to divide everything here by the 3 to get rid of that coefficient. Okay, so 3 divided by 3, that cancels out. And I get the absolute value of 4x minus 5 is equal to 7. Now that I've got that, I can finally break it up into those two pieces of 4x minus 5 equals 7 and 4x minus 5 equals negative 7. I'm going to do that off to the side just to give us some more room here. So our first equation will be 4x minus 5 equals 7. And my second equation will be 4x minus 5 equals negative 7. Same process as before now. So for the first one, I'm going to add the 5 to both sides. We get that 4x equals 12. I can divide by that coefficient 4, divided by 4. And we get that x equals 3. So far, so good. Let's look at the other equation. Let me see if I can scoot over a little bit here. Go ahead and add the 5 to both sides. So plus 5 plus 5. 4x, this time negative 7 plus 5 is going to be negative 2. I'm going to divide by that coefficient 4. And I get that x equals negative 2/4, which I'm going to reduce because I'm a good mathematician. And that's really just negative 1/2. All right, so my two solutions here are 3 and negative 1/2. Or 3 or negative 1/2 as our values for x. Basically, that's how you're going to solve these. We're going to get the stuff in the absolute value on one side, everything else on the other, then solve it for the positive and negative result. Are there special cases? Absolutely. Let's go ahead and go through one. Let's start off with this one here. We're going to start off just like we did before. I see My absolute value's got some stuff with it, so I'm going to do the opposite. I'm going to start off by getting rid of that 2. So let's subtract 2 from both sides. Negative 5 times the absolute value of x plus 1 is equal to 10. All right, so far so good. Now we're going to divide by that negative 5. And we get the absolute value of x plus 1 is equal to negative 2. Now here's a problem. We have a logical error because anything that comes out of absolute value bars has to be positive. And according to what we've got written down here, the thing coming out of the absolute value bars is negative. So this is a logic error. This is not possible. There's no solution. Easy enough, right? The stuff in an absolute value can't equal a negative number. How about another special situation, like this one right here? So what I'm going to do is start off just the same. I got the stuff in my absolute value bars. I want to get rid of the other stuff. So I'm going to start by adding 3 to both sides of my equation. Plus 3. So I get 3/5 times the absolute value of 2x minus 4 is equal to 0. That's actually super convenient. But Mr. Clark, what about the fraction? That's cool. We're just going to divide by the fraction. So let's go ahead and do that. I'm going to divide this by 3/5. 3/5 divided by 3/5 is 1. Fraction's gone. And 0 divided by 3/5. 0. We get the absolute value of 2x minus 4 equals 0. Okay? Well, this is normally where we would take our equation and break it into the two pieces, but there's no such thing as positive and negative 0. There just is 0. So really we can just solve it like a normal equation. Let's go ahead and do that. 2x minus 4 equals 0. Okay, so we'll add 4 here to both sides and get 2x equals 4. Divide by 2 and get my solution as x equals 2. So technically it's possible to have two solutions, which is what kind of normally happens. It's possible to have one solution if you end up in a case like this where it was equal to 0 at some point. And then you have the possible outcome of having no solutions if your absolute value is equal to a negative.